Perfect. Awesome. Thank you. So thank you everyone for joining us today. As a reminder, everyone's been muted just to cut down on background noise, but please feel free to drop any questions or comments you may have into the chat. We are very excited today to announce our keynote speakers for SEDLS 2024. Dr. Michelle Hribar is an associate professor of ophthalmology and medical informatics at Oregon Health and Science University. She was recently an NIH data scholar at the National Eye Institute, where she worked in the Office of Data Science and Health Informatics. She's currently leading a national effort to improve the standardization of ophthalmic data for research, which includes co-chairing the Observational Health and Data Science Informatics Eye Care and Vision Research Work Group, with the goal of adding ophthalmic data to the OMOP Common Data Model. Dr. Hribar originally trained as a computer scientist before retraining as a medical informatist at Oregon Health and Science University. Her NIH grant-funded research has focused exclusively on informatics and ophthalmology, specifically in the reuse of electronic health record data for research in both operations and clinical applications. So she's joining us today to talk about big data projects at the NIH, a report from an NIH data scholar. We're very excited to have you with us today. So thank you so much for speaking with us today, and I will hand it over to you.
Thank you. And thank you for that lovely introduction, and also for the invitation to speak here today. I'm really grateful for both Marla and Katie for inviting me. And I have to admit, my first reaction was, first of all, I'm not sure you guys are the data experts. So I hope I have something that additional to share and that'll be interesting to you. And then my other instinct was, I'm in Oregon, which is in the Pacific Northwest, which is completely opposite side of the country as the Southeast. So I hope that's allowed, but I guess it is. So I'll get started. It's not. Okay, there. I don't have any disclosures. And also, as I mentioned, I am joining you from Oregon, and wanted to start with a little bit of a land acknowledgement. And this is the formal one that's adopted by Washington County, Oregon, where I am. And basically, you can read it, but it acknowledges that I am on Kalapuyan land right now, and that land is, of course, very special. If any of you have been to Oregon, it's absolutely beautiful. But that, the ancestors of the people who actually had this land originally, the Kalapuyans, suffered a lot of injustice and sacrifice, and that we really appreciate that and want to work together to really enjoy and use this land and take care of it. So the agenda today is, I'm going to start with a short introduction about myself, and sort of the path of how I got to this whole world of data standardization. And then I'll give a little brief overview of some NIH data projects and initiatives. Many of you, I'm sure, will be familiar with a lot of them. And then I'm going to talk about what I did while I was a data scholar at the NIH. And I think it really does represent sort of a potential future for how to share data. And I'm going to talk about it within the context of ophthalmic data, but I really think it could be more broadly applied to any kind of biomedical data, but even outside of biomedicine. So my background, as Katie mentioned, is I have a background in math and computer science. I initially started working in high performance computing at NASA, but then decided that my passion was teaching, and I taught undergraduate computer science for several years. And then I wound up finding informatics and worked as the director of a biomedical informatics shared resource at Oregon Health and Science University before retraining and doing a fellowship in medical informatics and becoming faculty. And I just finished my NIH Data Scholar position. It was a 2-year sabbatical that I spent at the National Eye Institute, and it ended September 20th. And so now I am back being an associate professor at OHSU in ophthalmology and medical informatics. So, as all of you know, the National Institutes of Health is the world's largest public funder of biomedical research in the world. And it's comprised of 27 institutes and centers that focus on different aspects of biomedical research. We're going to focus a lot today on the NIH Office of Data Science Strategy. It's in the Office of the Director, and it was formed in 2018 to implement the NIH Strategic Plan for Data Science. And this strategic plan really focuses on the collection, storage, all of those things of data according to fair practices, as well as trying to foster talented and diverse workforce. I'm going to come back to this again and talk more about what the data scholar position is. But first, I'm going to talk a little bit more in general about data sharing and data generation projects at NIH. As all of you know, the NIH data sharing policy started in 2023. And I'm going to tell you a lot about some of the several resources and programs that can help with this process. But I'm sure as I this last 2 years have talked to various groups across the country, specifically about ophthalmic data standardization, which is a whole different aspect than data sharing. I give this very nice talk about what we're doing and the importance of data standardization and how they get involved. And then everyone just pepper me with questions about the NIH data sharing policy. So I am sure that all of you are also getting lots of questions about this and how to do it. So, and I'm going to talk a little bit about some of the resources that NIH has to help with this. Now, the first one is brand new. This was only announced at the end of August, and this is called the SEDLS Challenge. And this is it's a challenge. It's not a grant. And you submit ideas to, and it's actually implemented by challenge.gov, not even the NIH, even though it's run by the NIH. And they give out prizes for the best ideas. This is a 2-phase challenge. The first phase opens in April of next year, but I would highly encourage you to look at this and to look at the announcement because I really believe that data librarians are going to be the people that are going to come up with the best ideas for this. So what it is it's trying to create an index similar to the H-index for data sharing. But what they're looking for is innovative ideas for how to calculate this metric and what should go into that metric. And I think that all of you who are dealing with this every day probably have some really great ideas about what should be promoted as a good data sharing. Like, is it the number, if you have a data publication, is it the number of, future publications that cite that? Is it, somehow the quality of the research that comes out of that, that other people have built on that? Is it the number of data sets that have been built on top of yours? There's a whole bunch of different ideas. And so I'd really encourage all of you to, that probably have dealt with this a lot and have dealt with a lot of the other indices for publications to think about this and to get involved with one of these challenge submissions. Now, these other resources I think are probably more well known to you. There's the Generalist Repository Ecosystem Initiative, and this is really the NIH is trying to establish a common set of these repositories and that are going to have these, similar capabilities, services, metrics. They can be, and they've identified these 7 initial ones, and they're really trying to address all these different objectives for data sharing, including registering DOIs through DataCite that can link these data sets then to future articles, presentations, grants, patents, the whole thing. And and also to raise general awareness and help researchers adopt FAIR principles. I'm sure many of you have already dealt with a lot of these in here. They also have maintained a list of domain-specific NIH supporting data sharing resources. This isn't as cohesive as an effort. It's really more just a detailed list that provides information about very domain-specific repositories and where to find them. And so that sort of addressed maybe the F and the A of FAIR, finding data and having access to it. But I wanted to address the I and this interoperability aspect. And this is really the crux of what this data standardization is that I'll get into more. But this idea, so let's say you're a biomedical researcher and part of your research is you're collecting pain scores. So you are going to implement a 10 point, 0 to 10 point scale on how severe or mild your pain is. So you collect your data. Well, your collaborator instead decided to use a 6-point scale and use, sort of, emojis that sort of represent this. Now, when you try and harmonize these data sets, it's going to be very difficult because there isn't an obvious mapping from one to the other. So this is, I'm sure, something that a lot of you have already encountered before. And so really trying to come up with ways ahead of time so that you avoid these types of problems. So one of the ways that the NIH promotes for promoting interoperability, also for reproducibility as well, is these common data elements. And a talk earlier today, I heard a really great explanation of how REDCap can help with the use of these, which I think is fantastic. And it's exactly what the NIH is hoping for this. So the common data elements are just standardized, precisely defined questions and allowable responses. And the point is to try and use them systematically across studies. So not only can you harmonize data within a study, but also you can do better meta-analysis of across multiple studies. And the NIH really has a lot of different initiatives for this, as well as broader ones throughout HHS. So the NIH CDE repository is the first place to go. It has a great searchable set of standardized data elements for use in clinical research, as well as a link to forms, like case report forms that use these common data elements. Also, as was mentioned in the talk this morning, that they can be pulled into data collection tools like REDCap and My Data Helps. And there are some institutes that have their own repositories. So like NINDS has their own common data element repository. And there are also, that reminds me, there are also multiple data ecosystems within NIH. Another talk I saw this morning talked about the HEAL one. There's also a data ecosystem for Common Fund data projects. So I think the NIH can still do more work to try and kind of gather and harmonize between all these data ecosystems, but they're really trying to help with this. The other thing that I think is worth mentioning is that the US Core Data for Interoperability, or US CDI, is an effort that is trying to standardize data collection within electronic health records. And this is maintained by the Office of the National Coordinator for Health IT, which was once called ONC, but it's now known by its new acronym ASTP/ONC. And this is important because, and this will probably make more sense when I start talking about the research I'm doing, but if you're trying to use retrospective data from observational health that's been collected in EHRs, for example, then this would also help have better interoperability between them and better interoperability between EHRs. And this also is important for operations, clinical care as well, interoperability, but my focus is on research. So back to the Office of Data Science Strategy, they have additional programs that support data sharing, data science, all the good things. They have right now a DataWorks Prize for innovative data reuse projects, which I think is really exciting. It's for the reuse of data that exists in the Generalist Repositories Ecosystem Initiative, as well as they have multiple funding opportunities for data reuse, for building data repositories, as well as, and this is something I think is really important, is they've just come out with this summer a grant funding that's specific for a researcher. So in most or all of NIH funding, the PIs have to have a certain, faculty appointment within an institution in order to be eligible. And this is one of the first awards, at least in the research category, that allows someone that is not a faculty to actually apply for this. And it is meant to help foster the development of these really important software engineers, data scientists who are doing this really hard work that often don't get the recognition, nor do they often, they're also split between so many different grants and projects that they really have trouble, fostering their own career development and working on projects perhaps that are of their choosing. And I'd like to also mention for the S-Index Challenge that I think is important as well, that for that, I think one of the things that I think, and I have noticed in my work, is that a lot of the work that goes into curating those data sets and sharing those data sets are done by people who often don't get the recognition for those data sets. Those data sets are often linked to the PI of the project, and the people that are actually doing a lot of that data curation, data wrangling, getting that data ready for research and for sharing are not as well recognized. So I think the S-Index also has the opportunity for identifying and rewarding those, that recognition, as well as I'm really excited by this new funding opportunity that is also potentially going to help, foster the careers of these very, very important people in our world. Now, this gets sort of a long introduction getting into what the data scholars are. So this is another program that's run by the ODSS. And it stands for, just like everything else, the data actually is actually an acronym. It's Data and Technology Advancement National Service Scholar Program. And it was started in 2020 to advance data science projects in the NIH, as well as foster career development for people working in data science. And what started off as sort of a bug or kind of, maybe not ideal, since it was launched, I mean, it was started to plan before the pandemic, but launched during the pandemic, was that everyone wound up being remote. And since then, they have actually, I don't know if they'll continue to do this, but at least up until now, they have allowed people to become data scientists without actually having to move to Bethesda to do this. So I stayed in Oregon the entire time during my data science project, which I think is really important because a lot of folks, I think, would not apply otherwise, because this is really meant for faculty and people that have been established in their careers to then come and work on something at the NIH as a focused research project that not only helps NIH, but also helps that researcher gain more experience and more in time to really highly focus on one area. And they work on an individual project within the IC, or the Institute Center, that that their data scholar project is housed, as well as more NIH-wide work groups. I have a QR code here and a link to the page that has information about the most recent data scholars in 2023. It has not been updated for 2024 yet. I'm not sure what's going on, but the timeline for applications for the next cohort, the 2024 cohort, have changed multiple times. So they keep promising that this is going to be updated. So this link will work. eventually at pointing towards the projects for 2024 and applications for those projects. So the latest that they've told us is that, the new applicants are expected to start, even though it'll be 2024, projects will be starting in 2025. And the data scholars have been over 30 of us so far, and they've really spanned all aspects of biomedical data and research, and talking about standardization, infrastructure, modeling analysis. You have data scholars that have come from computer science. You have data scholars that are clinicians. You have people that are working in IT. It's really a broad mix of backgrounds and projects, which I think are really exciting. And there's different types of data that people are working on. So everything from genomic, imaging, EHR, clinical trial, even COVID test data. There's one scholar that's working on analyzing a COVID test data set. So it's really an exciting program. And I believe that most of you, if this is something that you're interested in doing, would be eligible to apply for one of these, as well as any of the researchers that you support at your universities. So my project at the National Eye Institute was improving the standardization of ophthalmic data. And we were really focusing on EHR data and trying to incorporate that into something called the OMOT Common Data Model, which I'll define in a little bit. But I really think, and the thing that's interesting about this is that I think it's a novel approach to fair data and might be the future, especially for sensitive, large clinical data, as a way of sharing and promoting reproducibility in this domain. But I think probably, one of the big questions I get all the time is, I'm a computer scientist, I'm an informaticist. Why am I working almost exclusively in eye care? Well, eye care is a pretty exciting field. First, I worked at the National Eye Institute, started in 1968, and it's the world leader in directing and funding vision research. And it really has a pretty impactful mission, which is trying to improve the quality of life of all Americans, especially for patients who are facing diagnosis of blinding eye disease and for patients that are impacted by blinding eye disease. And this is important. Americans consistently rank blindness as one of the conditions that they fear most, even more than other conditions such as cancer. And so, doing research in this area obviously is very fulfilling and is really, important. And it's something that I really find, someone who has worn glasses all my life and has had different ocular conditions, and something that I relate to very strongly. But probably the more important reason that I landed in ophthalmology is because data science is such an integral part of ophthalmology and ophthalmic research today. In fact, it is actually one of the emphases in the NEI strategic plan, which was recently adopted. And not only that, but it is a pioneer in AI. Most people think, when they think about AI, specifically when they think about it related to detecting biomarkers for disease in images, they usually think of radiology or something like that, but it's actually ophthalmology. There's been more research in ophthalmology, and ophthalmology has had the first FDA-approved autonomous AI for screening of a disease. So it's a very exciting field. But the other thing that I find very compelling and is something that is really driving the research I'm doing is there's this long ago saying that eyes are the window to the soul, but they actually have a view into the body as well. And this is something that, until I started working in eye care, didn't really fully appreciate. So eye imaging, particularly eye imaging that is looking at the back of your eye, the retina, is a view into systems that you cannot see any other way except through other invasive techniques. So it's a view into your vascular system. It's a view into your nervous system, the optic nerve. And they've already been able to find biomarkers for cardiovascular disease, for dementia, for neurological disease in retinal imaging, and often way before um, it's detectable by other means. And so, it to me, it sounds almost like a Star Trek type thing. The fact that in our future, we could go into Walgreens or something and look into a scanner and be able to be told that you need to follow up with this specialist because it looks like you might have, some sort of cardiovascular disease. Now, in order to build this vision, we need lots and lots of data, and we need diverse data from all Americans and all people across the world so that these models can work well for everyone. We also need really complete data about patients and their different diseases. We can get, in order to train an AI model to detect disease, we can get an eye image, but we also need to know what's going on with that patient so we can label that image appropriately, especially if you're doing some sort of supervised learning. And these data sets, at least, that have been done initially, have been prospectively collected, but we think that there is, and they're going to be continually prospectively collected, but we think that there's retrospective data, especially that's collected during clinical care, that could be useful as well. So some of the NIH-sponsored projects that have focused on data collection and data set generation are ones that I'll talk about right now. The All of Us research program, which a lot of you may be familiar with, is a research program that was originally conceived or came out of something that President Obama did in 2015 and 2016. And it was launched, and the goal is to collect really thorough diverse data about Americans, about 1 million Americans, and they really want to over sample patients that are typically underrepresented in our biomedical data sets. They have gotten data they're over halfway there so far, and it is really a thorough evaluation. I don't know if any of you have already participated, but that's blood collection, urine survey data, um, and they're actually going to be starting to collect ophthalmic data in imaging as well. So this will be a data set that also might lead to some of those biomarker identification for oculomics. Other data set generation projects that I think are important are the Bridge to AI initiative, and there are 4 funded data set generation projects. Some of you are probably already familiar with them, especially if you have researchers at your institution that are participating. Now that I'm officially not a data scholar anymore and I'm back to my civilian role, I am actually part of one called the AI Ready Project. And the goal of this project is to collect data about 4,000 patients with and without diabetes, and it's triple balanced according to race and ethnicity, stage of diabetes, none through severe, as well as sex. So, and it's collecting just an amazing amount of data, and it also represents a diverse set of researchers that are contributing toward this effort. So it's collecting all sorts of data about patients. It's getting lab tests, it's getting self-reported data, it's getting cognitive assessments, ophthalmic imaging, different types of labs. It's banking genomic data. They're getting sent home with Fitbit and getting activity data. They're getting environmental sensors, and they're also getting continuous glucose monitors. So it's a really thorough, amazing data set. Pilot data has already been released, and we are going to release our first formal a data set release for roughly 1,000 patients, and November 1st. Fingers crossed that works. But it's really a tremendous resource that it's going to be really valuable for all types of research coming up, and it really represents a tremendous effort that NIH is trying to invest in creating these high quality data sets that are, where the whole purpose of the project is to collect the data set as opposed to some hypothesis driven research in the data set that results from that. And so that brings me to now the focus of this other part, which is, can we use observational health data to drive some of this model generation in research? So observational health data is just a term that represents data that's collected during routine clinical care. So it's data that's in the EHR along with all of the other data that's collected as well, imaging data, genomic data, patient-reported data, lab testing data, the whole type of thing, and can also be collected, it can be connected to other data such as community level indices, through the census and social determinants of health. Now, we have a lot of this data worldwide, not just in the US, but it's siloed. And it can be very difficult, even for two researchers at two different institutions, but are on the same EHR and same clinical systems to share data and to do research. So we've come up with some different approaches. One is to pool data into registries or into data sets. And this works very well. The advantages are that your researchers can get a single access point to that data. The All of Us data is an example of this data set, as well as multiple clinical registries that are available for researchers to use. The drawbacks are that whenever you share data to a central resource like that, it has to go through extensive legal, privacy, and security agreements at each institutions, which can take years. I know at OHSU, there are a couple different ophthalmic registries that we contribute to. There's one through the American Academy of Ophthalmology called the IRIS Registry, as well as one at the University of Michigan called SOURCE. It took us, I'm not kidding you, 2 to 3 years to get our agreements through legal to actually start contributing data. The other drawback to this is that it's really not feasible for sharing large data. And in ophthalmology, the future of ophthalmic imaging are these large volumetric scans that are so huge that we just can't feasibly share them. They really can't be moved around. So another approach is what's called a distributed data network, or you may have heard it referred to as a federated network. The idea is the data stays locally at each institution, and instead what gets shared are the code and models. So federated learning is a big example of this, where your data remains local, and instead you have a coordinating center that's running sort of a global federated learning model, and each site runs their own local copy of that model and then shares the results, and it gets aggregated together. Also, there's something called Odyssey, which is the Observational Health Data Sciences and Informatics Network, which is based on the OMOP Common Data Model. And they do something called a federated analysis, which I'll talk about in a second. So this is really this is not to say that federated is better than the pooled approach, but it's a complementary approach, and I think is going to help us a lot, especially with sharing data that is potentially private or sensitive, and people are struggling with this ability to share it. If you can still keep it local, but really allow access to it through these different types of modeling techniques, I think is going to be a really important future for our field. So this data network is huge. It's around the world. It has thousands of collaborators, thousands of data marts that are stored in this standardized format. And my project was standardizing ophthalmic data so that it could be stored in the Odyssey network, because it's not formally part of it yet. So OMOP stands for Observable Medical Outcomes Partnership. No one ever refers to that full name anymore. It's just OMOP. And it refers to a public-private partnership that happened over 10 years ago. And it was between the FDA, the NIH, pharma, and academia. And the idea was that the FDA really wanted to be able to do post-market surveillance of their medical products past clinical trials. And they wanted to be able to standardize observational health data that was stored in claims data, electronic health records, so they could do these longer longitudinal type studies of outcomes of products as well as adverse events. The outcome from this partnership was the OMOP Common Data Model. And this is just a standardized database schema for storing observational health data, and as well as the conventions for storing that data. It's now been widely adopted. There's multiple data models, as I'm sure many of you know, across biomedicine. The reason we wound up focusing on this one is that it has been adopted by the NIH data generation projects, such as All of Us, National COVID Cohort Collaborative, or N3C, and Bridge to AI. So the AI Ready project that I work in, for example, uses the OMAP Common Data Model for its data set. And the Odyssey community, or Observational Health Data Sciences and Informatics, is now the community that came out of that partnership and maintains and updates the Common Data Model. But more importantly, and probably more interestingly for this community, is that it's been developing and maintaining tools for the appropriate use of this data and for reproducibility. So anyone that does data within this community has to publish their code, their model, even before anyone starts running the data. So all of this is reproducible. It really provides a great way for collaboration and reproducibility, and really, I think, is really supporting FAIR. So and that's not something that in the Odyssey community that we talk about a lot. But I really do think it is. I mean, it's obviously findable and accessible. Sites with OMAP data marts can join this Odyssey network. The accessibility I'll get back to in a second, but it's interoperable because all the data is stored within this common data model, or using the same common data model, and it's reproducible because they use publicly available modeling as well as phenotype development. So phenotypes in the context of Odyssey mean the cohort definitions for defining patients' groups of interest using this data. We all know that EHR data is not necessarily completely accurate, because a lot of the data that's in there, especially structured data, is for billing purposes, not for clinical care. So it's sometimes not obvious to be able to just use like diagnosis codes, for example, to find a patient cohort. You might need to kind of triangulate and look at medications. You might want to look at the number of diagnosis codes, that sort of thing, to define your phenotype, to improve the sensitivity as well as the specificity of your phenotype. So all this is publicly available and reusable for future studies. So I think it's a great example of a way that you can be supporting FAIR principles. The only asterisk I have is with the accessibility, is that accessibility is sometimes a challenge. So the people that are asking the research questions are often the people that don't actually have direct access to the OMAP data mart. So they have to rely on whoever in their institution maintains and runs network studies in their OMAP data mart. And just like anything across academic medicine and universities today, often doesn't have the resources. So that accessibility sometimes, comes with that asterisk that you need, often need funding to be able to do this well. But that's probably true of most research. So just to give you an example of how this can be used, a member of our work group, Cindy Kai from Johns Hopkins, did the first network study within our work group. And what she was looking for was the risk of kidney failure associated with intravitreal injections of anti-VEGF agents, in 3 different ones. And these are agents, they're injections. And if you're like me, every time you see the image of someone putting a syringe in someone's eye, you cringe. But for ophthalmologists, this and for patients, this has been life-changing for a lot of blinding diseases, this ability to inject these agents directly in patients' eyes. Now, these anti-VEGF agents have been used systemically in oncology and have been shown to have potential kidney failure as an outcome. It hasn't been prospectively studied in the intravitreal injection. So we know that this is a possible outcome. And for a lot of providers, they will preferentially prescribe ranibizumab because it has a much shorter serum elimination or half-life. So to try and counteract that risk of kidney failure for patients that they feel are at high risk for kidney failure anyway. The bad news is that ranibizumab is like 20 times expensive as the other agents. So this question can really have big consequences. So her question was really looking for evidence to see if there was that providers should be choosing ranibizumab to lower the risk of kidney failure. But long story short, when she did all the pairwise comparisons between the three different agents, she really found the hazard ratios all hovered around 1. So there really was no increased risk for preferentially for patients that weren't getting ranibizumab, for example. But the thing that's exciting about this is that this study was done in 9 weeks over 12 databases that represent a total patient population of 485 million patients, which is just a huge, population. Now, of course, within that, there were much smaller numbers that actually had blinding eye disease, and then even smaller that actually received one of these anti-VEGF agents. But this really shows the potential for using this type of studies in biomedicine. And we are currently working, in fact, this week we're submitting the journal article for this, but this was a study that was motivated by an article that was released on July 3rd in JAMA Ophthalmology that was done at Mass Eye and Ear, where they looked at their neuro-ophthalmology patients and they found a much bigger increase of something called non-arteritic anterior ischemic optic neuropathy, or NAION, which is can be a vision-threatening disease in patients that were on semaglutide or Ozempic. And we saw this study and we thought immediately that this needed to be studied in a much broader population, not just patients that are being seen at a neuro-ophthalmologist. It's a very niche specialty. Most of us probably will never see hopefully we'll never see a neuro-ophthalmologist in our life, but there are far more patients that are on semaglutide than are seeing neuro-ophthalmologists. So we're still finalizing that and releasing it. Spoiler alert, we did not find the huge hazard ratio that they did. If it was very modest, if any at all, it was maybe 1.28 to maybe 1.5. But it really shows, again, the power of this data and the importance of having this data available for research. This study we completed in 5 weeks, which is in 14 databases. So those are just some examples. These examples just use data that was available in claims data, in EHRs, diagnosis codes, prescriptions, procedures. We would really like to expand that to include ophthalmic data. And by that, we mean things that are collected during an eye exam. So visual acuity, how was your vision, your intraocular pressure, what's your glasses prescription, as well as ophthalmic imaging. Now, we have a lot of challenges that are common. Both EHR data and imaging data is not very standardized in our domain, which makes it very difficult to actually incorporate them, which is what our work group has been working on for the last 2 years, as well as the EHR data just itself can be challenging. So I co-lead the Odyssey Eye Care and Vision Research Workgroup and have done probably the bulk of the leadership during the last 2 years as a data scholar. And it's really this great multidisciplinary group of researchers. We're up to over 200 from across the world, spanning everything: ophthalmologists, optometrists, trainees, data scientists, informaticists, computer scientists, all interested in using this data for research and standardized data. And our goal is to get this data into these data generation projects, as well as building a distributed network. And there's a lot of different potential use cases for this. I mentioned oculomics. There's all sorts of, even having the data available to validate existing AI models or new AI models that someone's developing even outside the network would be just great, as well as being able to study rare diseases and study healthcare access and equity. And so our view of this data network is that it would have multiple contributing sites and having coordinating center. The coordinating center would do some extra work with having tool development that would make this network easy to use and work well with ophthalmic data, coordinate these studies and federated learning projects, provide training. But I also think there's an opportunity here to expand kind of the view of what Odyssey thinks is data. I think that either the coordinating center or even a contributing site could have a data set, but put into OMOP format. It's, an existing data set. Like, we're talking with some folks at different institutions that have data, like longitudinal data sets that they've collected about patients that they would like to make available for research. So having that stored in the OMOP format and have available, for example, like a federated learning imaging project, I think would be fantastic. And it would help provide that protection so you don't feel like you're just making your data globally available, the sensitive data, but by making it part of this federated network, and you could have the federated models be able to be shared with, at the site, be run on this data, and then report that data back, the aggregated results back. That could be a way of sort of alleviating a lot of people's concerns about sharing sensitive data. So the NEI thinks this is such a great idea that they've also created their own challenge related to this. And this challenge is actually active right now and has some upcoming deadlines. So if that's something that either you're interested in or you have ideas about researchers at your institution that might be interested in, please share this information. It's really a great and exciting project. And again, it's a prize for looking for innovative uses for this research data network. And as I mentioned before, the Data Scholar projects should be coming online any day now. And the next one for the National Eye Institute is focusing on FHIR, which is a different type of interoperability standard. And we're really excited to see how they expanding the standardization into other standards, such as FHIR, can help with this whole effort. So just in summary, NIH has a lot of different resources, I'm sure that you're aware of as well, for supporting data sharing and promoting FAIR principles. And there's also a lot of opportunities for career growth in data science and through NIH programs. My Data Scholar program really focused on one particular aspect of standardizing data into the Odyssey network, but I think that the Odyssey network and tools could really provide a new paradigm for fair data sharing. So, and if you want to contact me, here's my contact information and more beautiful pictures from Oregon. So hopefully that leaves enough time for any questions.
Awesome. Thank you so much for this wonderful presentation. This was fascinating to see it come sort of like the bird's eye view of things for like how this play out nationally and even almost globally. So this was really very interesting. Thank you so much. I also love the pictures of Oregon. It is just a beautiful area. If anyone has any questions, please feel free to go ahead and type them into the chat. I'll give people a little bit of time. It looks like Marla shared a couple of the links you mentioned in the chat as well, too.
Yeah, thanks for that.
I'll start us off. I think we've been seeing a big uptick in analyzing electronic health records, doing secondary analysis on that. And I find it particularly challenging to help people write data management plans for those, because the researcher isn't necessarily prospectively collecting data. They're given like a huge batch of electronic health records, and I think it's a bit overwhelming to consult with them on that. I wondered if you could speak to that.
Yeah, I find it overwhelming as well. And I am part of my job, as you might imagine, if I'm in informatics and ophthalmology, is I'm consulting on a lot of different projects that people have where they want to use retrospective EHR data. And it can be a challenge. I think, you know, I trying to align with standards is probably the best advice, but those standards can be incredibly difficult to find. In ophthalmology, the AAO, the American Academy of Ophthalmology, has a lot of resources on their website for data standards and which data you should be using. But like, I'll give you an example for visual acuity. It's collected in the EHR. It's one of the most important data elements that we collect about patients in you know, a factor in a variable in studies as well as outcome, but it's collected as a free text field. And so people can type anything they want in there. And on top of that, there's multiple different uh, ways you can represent visual acuity. So you can represent it as a Snellen chart value, so like 20/20. You can represent it as cycles per degree for little kids using teller cards. For patients that are have low vision or are visually impaired, you might have something in there like counting fingers or hand motion. For little kids, you might have something that's like central, steady, and maintained. And somehow we have to harmonize this all together. So we have to take this free text and then make sure that it's then transformed into something that's an allowable value. But then we still have to somehow harmonize all of that together. And, you know, that's one of the things that we've been working in our work group, trying to come up with methodologies for this that are reproducible and that we as a community advocate for and we expect people to use. But they didn't exist before this work group that we formed 2 years ago. So I can imagine that across other clinical domains, there's similar challenges. And so, you know, I think starting with some of the professional societies and seeing what's out there in terms of, you know, how is it that people, are there recommended ways to, first of all, use that data or to transform that data? The other one then is also challenging is this sort of phenotype or patient cohort definitions. And you can find some information about that. There's been some work across medicine in quality, data quality or clinical quality metrics and some value sets that have been defined where you can say, you know, like, how would you define like, you know, a patient with diabetes? What would be the agreed upon way of saying a patient has diabetes based on data that they have in the EHR? And it usually requires like up to 2 visits with that diagnosis. So there's these rules. So all of that can be quite overwhelming. And I'm not sure that as a field, we've done a very good job of really trying to help people navigate that. I will say the Odyssey community does a fabulous job of doing it within their world, but not everyone doing research in using EHR data is going to be doing an Odyssey network study. So I would love to hear from anyone else if they have anything that they've learned or resources that they can point to that can help researchers with this, because we struggle with this every day.
I'm not seeing any other, sorry, excuse me. I'm not seeing any other questions in the chat. There's a couple other Oregon fans up there and a coffee fan. Um, but yeah, this was really fantastic, just learning more about the data scholars and just everything that goes into it. So thank you so much again for being our expert speaker and our keynote speaker today. So that does conclude today's sessions, and we'll see everyone again tomorrow at 10 a.m. Eastern. If you've signed up for the Open Tools for Data De-Identification workshop, that is coming up next. That'll be its own separate Zoom link. But thank you again, Dr. Hribar. This was a really wonderful presentation. So thank you for being with us today, and thank you for everyone for joining us. Have a wonderful rest of your day, everyone.
Yeah, thank you.
Thank you so much. Have a good one.